So this is a typical network which we want to discuss now, okay, on the wide area network. So here I have a router. So likewise, I'm going to have 4 routers connected in a network, right? Each router is going to have its own local area network as well, okay? So a switch and host machine. So this means we have multiple host devices inside this LAN. Similarly, on R4 end, if we see a switch and the host device, right? And these 4 routers may not be in the same area, same location. No, it's going to be on, it can be in the same city or different state or different country, anything for that matter. Okay. So these 4 routers, how we are going to form a routing, like how we are going to configure IP address and enable routing. It could be dynamic or static, anything, but we are just going to see how IP addresses are being assigned on each interfaces, how it can be configured. So this router is having 3 Ethernet interfaces, gigabit Ethernet interfaces, that is, all 3 are LAN interfaces. Okay, so this interface is going to inside LAN. Okay, so this router IP address or this interface IP address should be 192.168.1.0 is the network defined for the LAN, local area network. So we are going to assign .1 IP address to the router, and the remaining IP addresses can be used for switch or any other host inside the LAN. So the network we are going to use for this particular LAN is 192.168.1.0/24. Right. So on the WAN interface, which we are going to interconnect between the routers, again, we are going to define a different network range only, shouldn't be in the same range. So it is 192.168.13.0/24 is defined here, but typically what we use in real time is a /30 network, not /24 on the WAN end. To connect 2 routers, we are not going to use, definitely we are not going to use a /24. Instead, we will be using a /30 network. So a /30 network will contain only 4 IP addresses. That's why we are using a /30 on the WAN side. So that is 192.168.13.0. Sorry. 1 second. Fourteen dot 192.168.13.1, 192.168.13.2, 192.168.13.4. Okay, so this is 192.168. 13.0/30. Okay, so this means in a /30 network, we will get 4 IP addresses, out of which this will be the network ID. And this will be the, what is this? This will be the broadcast ID of this network, and these 2 are the usable IP address. This is the subnetting concept. Okay, so in order to like use a /30 network, the benefit is, so one IP is assigned here, another IP, usable IP is going to assign on the other end. And there are no more IP addresses. And any packet that is being sent on this interface is not going to broadcast to any other IP addresses within this range because we have only two usable. So there's no broadcast is going to happen. But if we are using a /24 network, then there's a possibility like this network is being, since a directly connected network, if any other device is getting introduced between, we might not know the distance between the two router, but if anything happens in the middle, if a repeater or a hub or anything can be connected because it's a gigabit Ethernet, and we are going to, and if that device is being again directly accessed in 13 dot network range, if we are going to give a /24, because in /24 still we have enough IP addresses available free, not in use IP. We can use and easily like broadcast might happen or people can hack or do something, so that we are restricting the network range only to the usable IP addresses. Anyways, there is no requirement for any additional IP addresses on the WAN end. Only two routers? Yes. It could be of different office. This R3 router could be of different office, a directly connected office, or it could be of a service provider router, or it could be anything in the internet end. Fine. But even though if it is of any three options which are mentioned, it has to be assigned with a static IP over here that should be of the same network between the links. Same network, 192.168.13 network only. And a static IP only can be assigned on the remote interface as well, a known IP. So this administrator should know what IP is getting assigned on this router. He needs to contact the service provider, get the IP assigned, same network. So that is manual only. It cannot be dynamic or default, nothing. So it's better to use a /30 range. So it's just an agreement between you and the service provider on the other end. Agreement, okay, which IP you're going to use? Okay, I'll use the next free IP. That is what they are going to agree and they're going to use it. So it's better to use a /30 network. .1 and .2 on the other end. But in this example, we have given .1 and .3, right? So,
yeah, I think broadcast ID is wrong.
sorry?
I think broadcast ID is wrong.
No, your voice is too low. Can you repeat that again?
Can you hear me now?
You said something, broadcasted something. I didn't hear it clearly.
Yeah, I think broadcast ID is wrong.
Broadcast ID.
Hmm.
No, we are not going to use the broadcast ID also.
13.255, right?
13.255 is the broadcast IP. But that is not a usable IP.
No, you have written 13.4.
No, okay. 13.4 is the broadcast ID for a /30 network. If, see, 192.168.13.255 is the broadcast ID. For 192.168.13.0/24 network. Here I am using a /30 network. For a /30 network, we have only 4 usable IP addresses. So for any network, the first IP address is the network ID. The last IP address is the broadcast ID. I'm getting only 2 usable IP addresses in a /30 network with the subnet mask. I'll put the subnet mask over here. 255.255.255.252 is the subnet mask for /30 network. If my subnet mask is going to 252, then it's a /30 network. I get only 2 IP addresses. In this example diagram, it's a /24 network. In 24 network with the mask 255.255.255.0. Yes, this is the broadcast ID. 192.168.13.255 is the broadcast ID. Okay, but I am doing a subnetting process over here where I know only 2 IP addresses will be used in this range. Why should I waste the remaining IP addresses unused? Okay, and even when the packets are going to be sent, it is going to reach only the directly connected interface only. Apart from that, all the remaining IP addresses are still unused and we are not going to use for any host. So I don't want to waste any IP addresses. So I'm going to subnet the IP, minimize or optimize, and get the network.
Okay, got it.
Got it? Okay. So even say when I am splitting my network in this way, and I'm using a subnet mask of 252, and I'm going to assign this IP address. Say by mistakenly, if I'm using 192 on this interface, gigabit 0/0, I'm using 192.168.13.4 and using the subnet mask as 255.255.255.252, then the router itself will throw me back an error. Okay, say this is the broadcast ID for this mask and it cannot be used to assign it on the interface. So I cannot use this IP address. .4 and .0 is of same case only. If you're going to assign it, then the router is going to throw an error message. It's not going to accept this IP. Not even router, I'm saying in this matter, any network devices. Any network devices, if you're going to use the IP address wrongly, but defining the subnet mask like this correctly, it is going to say, no, this is the network ID you cannot use. This is the broadcast ID you cannot use. Or this IP is already assigned to another device in the same network. Okay, .1, I'm used in the switch and I'm going to assign it to the router also. It says, no, this router, this IP address is already active in the network. Okay, at that time, also it was going to throw an error message and it will say a log will come as a duplicate IP entry. So once if the duplicate IP is going to happen in the network, definitely the network will not perform. Network devices will be online, but since both the host devices are having the same IP, all the packets are being sent to twice to each host. Broadcast is going to happen within the network, and then the network performance itself will be slowed down and you cannot access any of the network resources. If at all, if you have any duplicate IP entry inside the LAN, that is for sure. And you will get the logs anywhere, somewhere you will see the logs like duplicate IP entry log, but you need to be very keen from where it is triggering the duplicate IP, to which device. Okay, you know, I'm logged into the switch, only the switch is having .1 IP, but the same IP is being learned on the different interface on the switch. So you need to trace down, narrow down the issue. Okay, this is okay. It's connected to a trunk. You will see, okay, .1 IP is being learned on the trunk interface by the show logs command in the switch. You should narrow down. Okay, the trunk interface, what device is connected to a trunk? Another switch. Okay, log into another switch. Check the same IP where it is getting learned. Likewise, you need to isolate the issue. one by one. Finally, we'll get to know, okay, this is the destination IP connected on this router port or this switch port, and then shut down the port. Once you shut down the duplicate IP entry directly connected port, if you shut down that port, then issue will be resolved. Then you can actually go check the device physically and change the IP address. That's how you can do. Okay, this is another troubleshooting in real time, which will happen regularly actually. Okay. Okay. So now you're clear with why we want to use a /30 network and what is /24 network, what is the broadcast ID for /24 and 30, right? Okay. So, so likewise, since this router is being connected to two different routers, again, it should be of different network range. I'm defining a network 192.168.13 range. Okay, 13 range for router 1 and router 3. Now 12 range for router 1 and router 2, because these two are again directly connected. Directly connected interface. Any directly connected interface from the router should be of same network range. Okay, this router is having 3 directly connected interfaces. Okay, so these 3 interfaces should be having the same network range. Okay. Okay, so I'm using 192.168 1 dot range in the LAN, and I'm using it on the router interface as well, 1.1. On the R3 end, I'm using 13 range, so 13.1 and 13.3. Next, for R1 and R2, I'm using 12.1 on the one end and 12.2 on the other end. Okay. So likewise, so what I'm trying to explain here is any router's directly connected interface should be having the same network range only. Okay. Same network range only. So this we should not forget. Even though if the router is connected to a switch, yes, same range. But this range and this range should not be the same range or same network. That is also important. So one router in directly connected interface is 192.168.1.0/24. The same network cannot be applied on this interface as well. If we are using same network, then what is going to happen? Then what's going to happen? You're going to advertise 192.168.1.0 network inside your LAN, as well as you're using it on the WAN router. So it's a kind of a duplicate entry for this network range. Again, there would be a what to say? There's going to be an issue in routing. So each interfaces should be of different network range on the router end. Okay. So next. So how we are going to assign IP addresses? Okay, so so say example R1 router. Let's take R1 router. It is having so it's everything in the global configuration mode. Okay, so first I am going to configure interface gigabit 0/2. Okay, I'm going to define an IP space address. What IP? 192.168.1.1. So on the router end, it is 1.1, 255.255.255.0. Correct? And just give us no shut command if we are going to use the port for the first time. Because by default, the port will be shut down in some routers when you purchase a new router. Manually, the ports will be in shutdown state. You can just give a no shutdown. Or if you're using a router for the first time, you're trying to activate any interface, just give a no shutdown command. It's not going to harm your interface or the network configuration. It's just going to activate the port. So just give a no shutdown. So next interface GI gigabit 0/1. 0/1. So IP space address for 0/1. What IP and well range .1 IP. 192.168.12.1. 255.255.255.0. No shutdown. Next, what is the other interface? Gigabit 0/0. That is also .1. So this is how I'm going to configure IP address to the interface. Sorry, this is not IP address. Interface. One 192.168.13.1. So I have assigned this on my interface on router 1. Similarly, same way we need to assign on the directly connected remote devices as well. Okay, so once you have configured these things, router command to see whether the interface is up is show IP interface brief is the command, just to see if all my interfaces, which is directly connected with the IP addresses assigned, are up. Okay, so you will see the status and the protocol. Okay, we will see the status and the protocol. So status as up. Okay, status as up or down or administratively. Administratively down. And protocol status as protocol status as only up or down. Okay. So up means status, link status, any of the link. I'm talking about gig 0, 1 and gig 0, 1 and 2 interfaces. After assigning IP addresses, when you want to check the interface status, show IP interface brief. The status under status on each interfaces, it will be either up, down, or administratively down. Up means, yes, IP is assigned. and a cable is connected, port is up. Down means, yes, you can assign IP addresses, but either the port could be faulty, or the cable which is connected is faulty, or the remote device which is connecting on that interface is not active or down. In that case, you will see down status as down. Okay, so if this port is showing as down in the output of showing IP interface brief, that means this physical port itself is faulty. Okay, or the cable which is connecting to this physical port is faulty, or the cable is not connected properly, a loose connection. Yes, port is down. Or the port is connected, the cable is connected on this interface, but this remote interface or the remote router is having some issue, or it is powered off or something like that, then this port will also show as down. Okay. Administratively down is nothing but if that port gigabit 0/0 is shut down. The port is manually shut down. Intentionally, the administrator have configured the port to be shut down. Okay, so we need to put a no shut in order to bring the port up. That is on the status part. On the protocol end. On the protocol end, it could be either up or down. So same case. Up is, yes, the physical port is up with the cable. If it is down, okay. So there is something wrong with the routing on the remote end, not physical, no physical issues on the protocol side. Okay, so it could be like the routing or the neighbor is having some issue on the routing part, or the service provider is having some issue. For that reason only, the protocol status will be down. Physically, there is no damage on the cable or on the port. Okay, so we need to check with the provider end. So we need to check with the provider in order to bring the protocol status up. We cannot do it individually. Right. So this is on the interface status and the protocol status, where we have assigned IP manually on the router's interfaces. Okay. So this is about router and routers directly connected interfaces, how we are going to assign IP addresses with subnet mask defined, and how the port status will look like. So on the routing end, like we have seen static, dynamic, just an outline of what is static and dynamic, and what is routing table will contain. What is a route means. Okay, what is next hop is. Okay, here in this case, the next hop for this router is what? This router and this router. So for next hop is nothing but the next router, directly connected router to reach the destination. R3 and R2 device are the next hop device for R1. Okay, so say for example, I'm going to define a static route. Okay, on the R1 router. R1 router to R3 router. Say R3, behind R3, I have a network 192.168. 3.0/24 network. Say here is one network for R1, R2 192.168 2.0 network, R3 192.168 3. network, and R4 192.168 4. network. So I'm going to define a static route to reach 192.168 3. network. Okay, so what is the static route syntax command would be is IP route source, sorry, it's not source, destination network Okay, destination network, subnet mask, and the next hop. Okay. Next hop. So here, if I going to use the actual IP address, how my static route will look like is IP route. My destination is 192.168.3.0. That's the network. I'm going to use the network only, not any specific IP address. Okay, in order to reach 192.168.3.network with its subnet mask 255.255.255.0, that means entire slash 256 IP addresses, any IP inside the 256 range. What is the next hop I'm going to use is 192.168. What is the next stop for this router would be is dot 3. What is the range? Sorry, dot 13.3. Okay, because this interface uses 13 range. So in that 13 range, dot 3 is the IP that is used on the router end. So that is my next hop. Okay, so this next hop should be if you not able to reach anything in the network, or if when you want to troubleshoot, try to ping the next hop IP first from R1. Try to ping 192.168.13.3. If you are getting reply, yes, your next hop or your remote device is online. So there wouldn't be any routing issue. If this is down when you ping, yes, there's a network issue. The router itself is, or the interface itself is down. Check on the provider end. Okay, this is the syntax or to define a static route. Okay, so this is to reach 192.168.3.network range. Likewise, you can have any number of multiple networks to reach to advertise from your router, but you need to be sure. To which next hop device it is being connected. To which next hop that should be defined. That cannot be dynamic. You cannot just blindly, okay, this network might be available behind this network, let us route. No, that routing will not work. Okay, you are unnecessarily advertising some network information on the router. So that is going to be a problem in your network only. So any routing should be done on the router end should be defined. Okay, I know this network is available over there only. And this is the defined next stop. So you need to mention it correctly. Okay. So this is the static route configuration. Okay. So any doubts here?
No,
Sorry, are you speaking something? I'm not able to hear anything.
no doubts.
No doubts. This is actually like you might have know these concepts, but it's just I want to
Yeah.
cover information. So next we have to look on the dynamic routing. Okay, so dynamic routing we have two different algorithms. Okay, that works on the dynamic routing. That will be distance vector algorithm and link state algorithm. Only on these two algorithms, the dynamic routing itself works. Okay, so in distance vector, we have two different. We have two routing protocols majorly used, and on the link state also we have 2, 3 routing protocols. So we'll cover the dynamic. We'll start with dynamic tomorrow. Here, are we good to wind up today?
Can you share this information?
Yeah, this, yeah, the syntax, right?
Yeah, everything is fine.
With the diagram.
Yeah, and even the previous class also.
Okay, I'll do one thing. I'll better share this document. This is okay, right? Because this is just something like incomplete, which is used for teaching purpose. Want to have this diagram. I mean, this document.
Okay, maybe after some classes you can share.
Yeah, I'm just adding up information in the same diagram. I mean, so in the same document only. Likewise, I have a text file also, right? With some commands and definitions in it. So I'll be sharing that. Okay, whenever
Okay.
is needed for you, JP, just let me know because I'll share it, or we'll just append and add informations in the same file, and probably when you need it, I'll share it.
Yeah, in next class, maybe you can open the notepad and type all the definitions.
Okay. No, I already have a notepad. I already have a notepad. Share with all the commands and all syntax. So far, we
No,
went
I'm
through the
talking about static and dynamic.
yeah static dynamic. I have it here, right? I'll share it in the next class.
Okay, thank you.
Okay, then we'll meet tomorrow then. Okay.
Okay.
Yeah. Thank you. Bye.